All right, so this question says, considered when 0.025 molar CO2 plus ions are used in the cathode and 0.75 molar Fe2 plus ions are used in the anode. Find the potential under non-standard conditions, and it tells us that 2 moles of electrons are transferred, which we could see from the reaction. So we've already found the standard E cell for this, and we used it in the previous question and in a few previous questions from that. We actually found it, and it's 0.784 volts. All right, so what we need to do is we need to figure this out under non-standard conditions. So this assumes that this concentration is 1 molar and this concentration is 1 molar, but in this case they're not. And here under non-standard conditions we need to use what's called the Nernst equation, which is E cell, not E naught cell, standard conditions, equals E naught cell minus 0.0592 volts divided by N log Q. All right, and this partially explains why batteries will lose voltage over time, because the concentration will change, okay, through time. Specifically, this concentration will decrease over time, okay, as the CO2 plus forms Cu, and this concentration will actually increase over time as the Fe forms more Fe2 plus. So Q is the same as K, just under non-equilibrium conditions. So Q is products over reactants, but in this case, the only product that's aqueous is the Fe2 plus, and the reactant that's aqueous is Cu2 plus. Since we have iron and copper, they're solids, they don't get factored into the Q. So Q equals 0.750 molar divided by 0.0250 molar, and then Q is equal to 30. All right, now we can just plug in. E cell equals the standard cell potential, which is just reduction minus oxidation, okay, just like before, except we had figured it out before, so I'm not going to redo that. It's 0.784 volts minus 0.0592 volts over the 2 moles of electrons that are transferred times the log of 30. Okay, and when you do that, E cell comes out to be 0.740 volts. So it doesn't lose a tremendous amount of voltage as the concentration changes, because here it's actually 30, so you have 30 times more of this. But it does lose a small amount of voltage as the concentrations of the products and the reactants change.